In this video, we're going to talk about inequalities in triangles to be able to tell which sides and angles are going to be the longest if we're given different pieces. So in this first one, if you draw the same triangle I've got on here in my red one, so the obtuse scalene triangle, and I want you to mark the largest angle and the longest side in red, like I've got. Again, there are my dogs. Then in my second triangle, I have the same triangle again, but I want you to mark the smallest angle and the shortest side also in blue. And what do you notice about them? So if you notice with the red one that the longest side is across from the largest angle, so it's opposite the triangle. And the same is true for the smallest angle and the shortest side. So the shortest side is across from the smallest angle in the triangle. The best thing to do is to draw an angle across from it like I've got, because then it definitely points out what is the largest angle or the longest side across from what you are given. So now if we use that same idea to compare different pieces in our triangle, if one side of our triangle is longer than another side, so my 8 right there in my triangle, then this angle that's opposite the long side or longer side is going to be the larger than the angle opposite the shorter side. So that seems very wordy, but basically because the 8 is bigger than the 5, then we know that the angles that are across from them, so my angle C corresponds with 8, my angle A corresponds with 5. It doesn't mean that that's the actual measure, but it just corresponds with it. So since 8 is bigger than 5, then we know that angle C must be larger than angle A as well. So the opposite is also true. So if we start with the angles instead right here, then we can say something about the sides that are across from them. So in a triangle, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So in my picture again, if you can kind of see, the 50 degrees is bigger than the 30, which means that the side that's across from each of those, so that would be BC for my 50 and AB for my 30 degrees, I color-coded it again, that means that those sides also correspond the same way. So since the 50 goes with the BC, then I know that BC has to be larger than side AB just based on the angles. So using that information about the opposite angles, we are going to draw in as I talk about this first one. So it says Jenny is constructing a stage prop that shows a large triangular mountain. So we're going to use this one here in front to make our markings on. The bottom edge of the mountain is 32 feet long. The left slope is 24 feet long. And the right slope is 26 feet long. Jenny is told that one of the angle measures is 53 degrees and one measures 48 degrees. What is the angle measure of the peak of the mountain? Okay, so first we need to find out what the missing measure is of the angles. So if you remember, all three angles need to add up to be 180 degrees. So if I take 180 and I subtract out the 53 and the 48 that we already have, then our missing angle is 79 degrees. Okay, so if you notice that we need to now compare the longest side over here, my 32, needs to be across from the largest angle. So that means that this angle right here has to be 79 degrees. My smallest side, so my 24 feet, has to correspond with my smallest angle, so across the triangle from it. So over here in the lower right should be my 48 degrees. And lastly, my medium side then, I usually choose that one last so it fits in the middle, that it needs to correspond with the middle angle, so that would be the 53 degrees, and then it has to be across from it. So over here in this lower left corner is 53 degrees. So to answer her question of which angle is going to be in the peak of the mountain, that is our 79 degrees. So now I would like you to try this next one. So this time you're starting with the angles, and you need to list the sides in order from smallest to longest, or shortest to longest. So go ahead, push pause, work it out, and when you're ready to check your answer, you can maybe push play. All right, so one thing that you could do with this to help is if you list your angles first from smallest to largest, and then that way you can list these sides that correspond them underneath it. And then that would be really what our answer is going to be, are the side answer, not the angles. So for the angles, for the smallest angle is the 29 degrees. That would be our angle R. So next, with the angle R, the side that goes with it, if you look across the triangle, is the side ST. So ST then will be the shortest side. So next we go back to the angles. I usually skip the middle one and I go for the longest one. So the largest angle is my angle S over here. So that means that my largest side to go with it then will be across the triangle. So that would be my RT. And then for the leftover angle in the middle, that's what I usually leave as last, is then my 30. So that is my angle T. So the side that's across from my angle T then is my RS. So remember, they're asking for the sides, not the angles. So we want our answer in blue that I've already got boxed out. Double check to make sure we went from shortest to longest. That will switch from question to question, so be very, very careful with that. For the triangle inequality theorem, this is more to see, can we create triangles given different side lengths? So if we take the sum of the lengths of any two sides of a triangle, and it needs to be more than the third side in the triangle. So if you look at the color coding on here, that doesn't matter which sides you are given. So if they add two sides together, it needs to be greater than the third side. If they choose two different sides, then it has to be greater to the third side. Or lastly, if they take two sides, then it has to be greater than the third side. So what a main thing that you want to remember is this right here. So you might want to put a star or something by this. But if you add the two smaller sides together, that should be more than the third side. And if that works, then that should work for all three scenarios. You don't have to check all three scenarios to see if they work. So for this first one, my side 3 inches and 6 inches are my two smaller sides. So if I add those together, so 3 plus 6 is 9. Is 9 greater than the third side? And yes, it is. So yes, this would make a triangle. So next we would do the same thing again. So 7 plus 3, those are my two smaller sides, equals 10. Is 10 greater than the third side? And the answer is no, it is equal to it. It has to be exactly greater than. It cannot be equal or it will not create a triangle. So I want you to do the next one. So if you have side lengths of 10, 12, and 25, add the two smaller together and see what you get. So if you add your 10 and 12 together, we get 22. And is 22 greater than 25? Definitely no, so that one would not make a triangle either. So using that same idea is if we are given two side lengths, so 12 and 8, but we do not know what the third side length is, we have to come up with a possibility of a range of numbers that would work, that would still create a triangle. So what you have to think of is two scenarios. If 8 is the smallest, and here's my little picture to show that, then I would take 8 plus 12, and I know that equals 20, and 20 has to be more than the third side. So this means that the third side has to be less than 20. So that's the top end. Next, we have to think if 12 is the largest side instead of the medium side. Then that would mean that I would take my 8 plus y, so my unknown, and it needs to be greater than the third side. So if I do that, then that means that the third side has to be greater than 4. So if I write it as an inequality, I would have 4 less than, so I would have 4 less than x less than 20, and this would be my answer, how I would leave it. So there's two individual ways of doing that. If you notice, over here on the right that I'm subtracting. So I take 12 minus the 8 to get the 4. And then for the other number on the left, I'm adding the 8 and the 12 together to get the 20. So for one scenario, you're going to add, one scenario, you're going to subtract them, and that gives you your two separate numbers. So now I want you to try it the same with the 11 and the 15. All right, so we already know the setup of what this is going to look like. So we just have to fill in our two numbers. So to figure out the smaller range, if we take 15 minus the 11, we get 4 again. For the top range, if we take 11 plus 15, we get 27. So the top range that we could have would be a 27, and there is your answer. Sorry, that's a 26, not a 27. I just caught that myself. On this question, I want you to do this one on your own, and there's two parts to it. So first, you have to tell me, do these three side lengths given, do they create a triangle, yes or no? If they do, then I would like you to order the angles, so not the sides, but the angles from least to greatest. So go ahead, figure out your answer. You can draw a triangle then afterwards if you need to, and then answer the question. When you're ready to check your answer, you can push play. All right, so in this one, you have to figure out what the decimal answer is of the 4/5. So the 6 is still just a 6. The 4 square root 5, sorry, 4 square root 5, not 4/5. 4 square root 5 is the same thing as 8.9. And then we still have the 12. So the two smallest sides are my 8.9 and my 6. So if I add those together, we end up with a 14.9. And 14.9 is bigger than the third side, so yes, it makes a triangle. Sorry, my dogs are fighting in the background. They love to wrestle at nighttime and be kind of obnoxious. So next, if we draw a triangle with our measurements in there, since we know it makes a triangle, then we can that will help us answer this last question. So one thing I had said before is if we list out the sides from least to greatest, then we can pair up the angles that go with them. So the smallest side is my side with the 6, so my CB. My largest side would be my 12, so my AC. So the angle that go with those, the angle that goes with CB is my angle A. The angle that goes with my AC is my angle B. So if you notice, that's the smallest and the largest, and now I go back for the middle one. So this middle side that I haven't done yet is going along with my 8.9, and that's my AB. And then the angle that goes with that one is my angle C. So I go from least or smallest to largest for my angles.